So welcome everyone. This is a free webinar that we do periodically here at TTP to give you some insight into particular aspects of the GMAT and to help you get to know some of our instructors. So my name is Céilidh. I've been teaching the GMAT for a very, very long time, over 13 years now. I love teaching the GMAT. I love how complex and frustrating and annoying this test sometimes is, and I'm excited to help give you some insight into some particular aspects of the test. So what we are getting into today is specifically data sufficiency. So I'm going to share my screen here, and hopefully you can see the PowerPoint here. So we're going to be discussing data sufficiency, particularly as it relates to word problems, the kinds of word problems where we are translating into equations, those systems of equations. And then we're going to look at how the GMAT likes to set traps there. But first, a little intro. My name is Céilidh. As I said, I have been teaching the GMAT for many, many years, but I also have a master's in educational neuroscience. So I really like to nerd out about how people learn and how to basically structure learning programs to maximize your learning outcomes. So I am very excited to be here with all of you. All right. Let's dive in, shall we? Our agenda for today, we've got a lot to cover, but I think we can move through it. We are focusing on data sufficiency, and we'll talk a little bit about strategy, how you should approach this question type. So if you are brand new to the GMAT and you've never seen data sufficiency before, we'll talk a little bit about what the question type looks like and how to approach it. But I'm going to assume that a lot of you have been studying for a little while and that you are familiar with this question type. So if you are brand new, if this feels like it's moving a little too quickly for you, I recommend reading the chapters on data sufficiency strategy, but hopefully we'll be able to follow along. And if you have any questions, you can always put those in the chat throughout our session, and I will try to respond to those as best I can while I'm talking here. So, reviewing some data sufficiency strategy. Wow, I can't even say that. Data sufficiency strategy. And then we're going to be talking specifically about systems of equations. There are going to be some shortcuts that we can use to make our lives easy and to avoid doing laborious math. But also, we're really going to focus on the idea of traps. How does the GMAT know where we want to take a shortcut and then not let us take that shortcut? So without further ado, let's take a look at data sufficiency and how it's structured. So these are the basics. Take a moment to read through this, and then what I would like you to do during this class, if you're answering questions, instead of putting that in the main chat, send it to me as a private message, a DM. So you are welcome to DM me your answer, and that way I kind of know what people are thinking. So give this one a try. All right, seeing some answers coming in here. So I want to talk a little bit about the structure of data sufficiency in general, and then we'll talk about this question in particular. So a few things to note about data sufficiency. You're always going to get one question, and it's going to be a question that you can't answer all by itself. How many students are there in Professor Erickson's class? Also, did you guys like that I just gave myself a PhD here, made myself a professor? I don't actually have a PhD, but that's okay. So you get a question, and then you get two statements that are trying to help you to answer that question. And then you get these 5 answer choices. These 5 answer choices will always be in exactly this order. So it's a good idea to memorize these answer choices, memorize the order that they're in so that you don't waste any time on test day reading through those choices. So on the real test, they will be bubbles. They won't actually have letters that go with them, but of course, when you are studying, think of it as A, B, C, D, and E. And in this class, I'll give you a cheat sheet, little shorthand when we do that, but I really recommend memorizing these answer choices so that you don't waste time on test day. And then the other thing to know is that these statements are always true. They're always there to try to help you. They're not trying to mislead you. And if they're both true, they can't contradict each other. So your task is not actually to find the answer to the question. It's to find out if the statements give you enough to answer the question. So, stepping back to the question alone, how many students are in the class? We're looking for a value, and it will be sufficient only if we get down to one and only one value that works. So you might write this on your paper as something like S equals what? We're looking for that value. When we look at that first statement, there are more than 15 students. Okay, so that number of students is more than 15. All right, but it could be anything, right? There are infinite numbers greater than 15, so that's not going to give us enough information. Definitely statement 1 alone, not enough. But if statement 1 is not alone sufficient, then we can rule out both A and this one here, E, that says each alone is sufficient. So that's not it. So then we look at statement 2. And here's the important part. When we look at statement 2, we have to pretend that we never saw statement 1. Erase it from our memory. Basically, give yourself temporary amnesia. Pretend you didn't know it. And look at statement 2 by itself. If 3 students leave the class, okay, so then the amount that we have now, minus 3, that amount would be then fewer than 14. You might have looked at this statement and not done anything with it because, again, it's giving us something open-ended. But if we did manipulate that algebra a little bit, we could add 3 to both sides of that inequality and say that S must be less than 17. But again, that's a range. It could be 16, 15, 14, 13, 12, etc. That alone is not enough. So we can rule out statement 2 alone. Answer choice B as well here. So then only after you have evaluated the statements on their own, then you can put them together. So now we can look at statement 1 and statement 2 together. Now let's combine those. I'm sorry, there's not much room on the screen here, I realize, but let's combine these as an inequality. Greater than 15, but less than 17. Okay, we can make that a 3-part inequality. S is between 15 and 17. Now, that is an inequality. It doesn't give us a value, right? So does that mean that we don't know? But I'm actually seeing a lot of you in the chat saying that that actually was enough. How is it possible that an inequality is enough to answer a value question? Well, with students have to be integers, right? You can't have half a student. You can have students who are half paying attention, but that's not the same as having a half student, right? They have to be whole numbers. And there's actually only one whole number between 15 and 17. And because this was not a less than or equal to situation, right? It was a less than sign. We know that S has to be 16 and we've answered the question. So both statements together are sufficient, but neither one alone. All right. So this is how we want to approach these questions in general. As we said, answer choices are always in this order, statements are always there to help. And our big takeaway for how to approach these is evaluate each statement separately. Look at each one on its own merits before you put them together. All right, so that's the basics. I know a lot of you have done a lot of work with data sufficiency, so let's step it up a little bit. Let's make it more complicated. Give this one a try. And again, send me a DM when you have an answer. Okay, let's take a look. I should say when it comes to timing, by the time you're ready to take the real GMAT, data sufficiency are questions that you want to move through a little more quickly than some of the other questions on the data insights section. So ideally you want to move through these in about 1.5 minutes. I gave you 2 minutes on this one. I was being a little bit nice. And when you're at the beginning of your study process, obviously feel free to give yourself a little bit more time. But then as you're ramping up, you want to be doing timed sets that kind of mimic the feeling of test day. So 1.5 minutes for these is usually the right idea. So before we look at these statements, I want to block these out for a second. One really important thing for us to do when we're approaching data sufficiency questions is really make sure that we are carefully defining the question. What do we know from the question stem? And then what are we wondering? So resist the urge to jump right into the statements really quickly, and instead step back and say, okay, what do we know already? We're told that this was a total of 500,000 given in grant money to these 4 finalists, Wei, Xavier, Yael, and Zainab. Let's just call them W, X, Y, and Z. Hey, notice that? So there is a relationship that we can already set between these variables, if we set W, X, Y, and Z as the variables for amount of money that each received. Anyone in the main chat, tell us, what is the equation that we could derive from the givens here? We could say that W plus X plus Y plus Z equals 500,000. So we have one relationship, but we have 4 variables, right? So obviously we're going to need a lot more information than that. If we're looking for Z equals what? Well, in order to find that, we're going to need some more information about the other 3 variables. We're going to need enough, either the values of each of those other variables or enough relationships to be able to solve here. So let's look at the first statement. Way received 60%, Xavier received 5/8. We absolutely could create some relationships here. W equals 60% of 500,000. Xavier is 5/8 of 40% of 500,000. We could, but actually at this point, we know that this is only giving us information about 2 out of our 4 variables. If we have 4 variables, we're going to need some information about all 4 of them. In fact, generally speaking, how many relationships should we need in order to solve for 4 variables? 4, right? 4 variables, we should need 4 equations. More on that later. In this one, we know that we're only getting information about 2 of our 4. There's no way that that can be enough. So in fact, thinking about our answer choices, we can eliminate A and D right away. We don't actually have to do that math. Now we want to look at statement 2 by itself, pretend we didn't see what we saw from statement 1. Okay. Yael and Zainab each received some number less than Xavier and some number less than Wei. Okay. Well, is this enough? Here is my question. How many relationships can we derive here? We could actually write 3 equations based on the information, because that word each is doing a lot of work here. That word each is telling us that Y equals Z. And then in terms of Zainab, who we're solving for, we could say that Z is Xavier's amount minus 87,500. And then we could say that Z's amount is Wei's amount minus 262,500. Okay, so what was the amount that Zainab received? Trick question. We don't care. Do not actually do that math. These numbers are messy, they are complicated, and our job is not to actually solve here. Our job is to figure out if we have enough to solve. Well, here, if Y equals Z, then we can plug a Z in here. If Z equals X minus something, we could plug in for X a Z plus 87,500. For W here, we can plug in a Z plus 262,500. I'm not actually going to do that math. I know that when I put all of that together with my original equation, that was way too big an arrow, we're going to get a Z plus something plus Z plus something plus Z plus something. In other words, we're going to end up with a 4Z plus some number, I don't care, equals 500,000. So I am not going to bother doing all of that math, because I know that if I did, I'd get a value for Z, but that's not my task here. We have enough information to get a value, and so the answer is statement 2 alone is sufficient. B is our answer here. So one big takeaway, well, 2 big takeaways on this one. Number 1, reframe, define what you know from the question stem, and then think about, what do I need to answer that question? Then look at each statement individually and resist the urge to collapse them together. A lot of people answer C on a question like this. And yeah, it does work if you put them together. But C actually is together they work, but separately they don't. So we have to evaluate them separately first. And by the way, how much did Zainab receive? The correct answer is it doesn't matter. Do not do the work to actually solve here. Stop as soon as you know that you have enough information. Don't actually do the labor of solving it. All right. Let's take a look at how the GMAT can then take these ideas and make them a little more complicated. So, takeaway here, do not calculate, because data sufficiency isn't actually asking us to calculate the numerical answer. Instead, we're being asked whether we could produce an answer. So stop as soon as you know that you have enough. You don't actually need to do the work. But sometimes you do. We're going to look at the cases where you do actually need to do the work versus times when you don't. But put a pin in that for now. First, I want us to talk about some algebra basics. The bread and butter of basic algebra, systems of equations. So you guys learned this in middle school or high school, the golden rule. If you have 2 variables and 2 equations you can solve, 3 variables and 3 equations you can solve. Our last one, it was 4 variables, 4 equations. So that's kind of the classic. If they give you 2x minus 8y equals 6 and x equals 5y, what is the value of x? You know that you can put those 2 equations together, get a unique value for x and a unique value for y. We can think of those as 2 lines that intersect on a coordinate plane if we want. But the idea is we can solve as long as we have 2 equations for 2 variables. I'm not going to make you actually do the work to solve here unless you really want to. But just, we trust we're going to get a value for x, we're going to get a value for y, right? So we can take that idea and apply it to data sufficiency, as we did in that last problem, and really shortcut the solving process. So if we just take that and flip it around into a DS question, what is the value of x? Statement 1 gives us one equation. Statement 2 gives us another equation. Well, neither equation is going to do it by itself, right? But if we put the 2 equations together, we have enough. And the answer here would be C. So that's kind of the way that we can use data sufficiency to find some shortcuts here. But I do want to point out something important. Some of you may have started studying for the GMAT before January of this year. If you did, data sufficiency used to exist in the Quant section. Now with GMAT Focus, the move to GMAT Focus, they've moved data sufficiency from Quant to data insights, and they changed it ever so slightly. Most of the questions will be exactly the same, but they've just taken out the pure math, as they say, questions. So you wouldn't actually see a simple algebra question like this one. What is the value of x? And then 2 equations. This is what they would call pure math. So that's no longer going to exist in data sufficiency. But what is going to exist is word problems that you would then turn into simple algebra. Oh, so I got a question in the chat that asks, what if you had a system of equations that had no solution? The GMAT's not going to do that. Like if it was like 2 absolute value equations where it turned out that none of the solutions were valid or something like that, don't worry about that. They're not trying to trick you with that sort of thing. And because there is no pure math tested, it's now all going to exist within word problems. We'll take a look at those. You should assume that there is a real solution to those problems. And like, if it's a problem about people and the money they received from a grant, it's not going to be like imaginary numbers or even negative numbers, right? So all of word problems on the GMAT exist in the real number space, and will conform to real world logic. Prices are never negative, can have half a student, things like that. So take a look at these 2 word problems. and see how they would turn into systems of equations. And then if you want, DM me your answers, A, B, C, D, or E for each. Okay, let's take a look. But first, why on the GMAT or on a math tests in general are people buying fruits like this? This reminds me of one of my favorite tweets of all time. Yeah, who out there needs 25 mangoes? Who out there needs like 10 pomegranates? These are ridiculous numbers of fruits. Oh well, doesn't matter. Doesn't have to be realistic, right? So let's come back to these two problems and think about how we can just define these as systems of equations without doing too much work. So for the first one, okay, watermelons, cantaloupes, how much does the preventer charge for one watermelon? So basically the price of a watermelon equals what? That's what we want to know. There's nothing given here in the question stem. So we look at the statements. In the first statement, 3 times the price of a watermelon plus 5 times the price of a cantaloupe would equal 54. Well, that gives us one equation, but we've got 2 variables, so that's not going to be enough. Statement 1 alone is not enough. We can get rid of A and D there. Statement 2, similar idea, 4C plus 2W equals 40. Once again, we've got one equation with 2 variables in it, not going to be enough by itself, but here, if we put these 2 equations together, 2 equations, 2 variables, that is going to be enough. So the answer to this one was C, if we use them both together, 2 equations, 2 variables, and I hope you didn't do the work, or well, since we were just talking about don't do the work, probably most of you didn't do the work to figure out what the value of watermelons actually is. And Ava, are there instances that one equation can solve for 2 variables? Was the question in the chat. And the answer is yes. Hold that thought. We will get to that in just a little bit. So for the second example here, this one was different because we got some information in the question stem itself. We were given that 1 pomegranate plus 1 durian equals $14. By the way, you guys, I wrote this question and then later I looked up how much does a durian actually cost? And they cost like hundreds of dollars. So this is not realistic. I've never purchased one myself. So shame on me for being ignorant. I thought that they would be an amount that, but anyway, this is not realistic. This is not how much durians cost in real life, but we do have an equation in this universe for the cost of one of these and one of these. So we already have one relationship between our two variables. So now all we need to be able to answer the question is one more relationship. In statement 1, we're given 3p equals 15. Well, hey, that allows us to solve for the value of p. We can definitely plug that in and get the value of d. I don't care what the value actually is. I just care that it's gettable, which it is. We're good. That's enough. In statement 2, 10p plus 5d equals 95. All right. This is another relationship between our two variables. We'll be able to combine that with the relationship we were given up top, 2 equations, 2 variables. That'll solve it. So each one alone was sufficient combined with our given information. Pretty classic, right? You will see questions like these on the GMAT. Sometimes they'll just kind of serve you up a 2 equation, 2 variable situation where you need both, and it's pretty predictable. It's what we expect it to be. But sometimes they like to throw curveballs, so I want us to take a look at some twists on that idea when the 2 equation, 2 variable thing is not what we expect. So all I will say in advance is be prepared for some traps. All right. Take a look at this set. DM me when you have answers. Okay, let's take a look. One thing that my students know, and hello to those of you who are here from some of my classes or former classes, great to see you. When I'm writing my own versions of official guide questions, I always like to make the people with crazy Irish spellings, just, because here I am, Céilidh. And so I like to pepper in some Irish names. So we've got Niamh and Roisin and Owen and Cleanna and Orla. Of course, right? Would never have expected any of you to know how to actually spell or pronounce those, but let's look at what's going on here. It really feels like the answer to all of these should be C, right? In each of them, we've got two unknowns, new and used games, lambswool and cashmere, candy and popcorn, and then we have two statements for each. It feels like they all should be C. But it's a trap. None of them were C. So I want us to look at why. On this one, here is where my advice earlier of like, just see if you have two equations is actually not enough. Because sometimes the GMAT will give you two equations and you don't have to do the work. It'll just turn out that you'll get two values. But something really sneaky was going on here. If anyone found it, go ahead and tell us in the main chat, what is the sneaky thing going on in this problem? It's the same equation. We wanted to know n equals what? And each of the statements did give us a relationship between n and u. 3 new plus 4 used equals 107.5. Okay, great. But when we get to the other equation, if we rearrange it, 6n plus 8u, that's starting to look kind of familiar, 215. What if we divide through by 2? Then we get 3n, 4u, and 107.5. These were actually the same equation. And if two statements are telling you exactly the same thing, putting them together doesn't help. It doesn't give you any more information. And definitely each statement alone wasn't enough because we need one value, but each of this just gives us one relationship between two variables. So it was E, not sufficient, even when we put them together. So the trap here that we want to be careful of is that, yes, the rule is we can solve if we have two equations for two variables, but sometimes it looks like they're giving you two equations, but they're not really two different equations. They're two versions of the same equation. So what you want to do is do just enough work. Basically, write your equations down at least and confirm that they're not secretly the same equation. All right. Any questions on that? It's sneaky, right? It's so annoying because, like, on the one hand, we don't want to do too much hard work, but then we need to do just enough in cases like this. Okay, there was a trap in this one as well. If anyone found it, go ahead and tell us in the chat, what was the trap in this one? Why is the answer not C? Well, let's define the question here. How much did she spend on 2 lambswool sweaters and 1 cashmere sweater? So in other words, you might have written this down as 2L plus, my screen just froze there for a second. 2L plus C equals what? This is our question, right? So when we're looking at the statements, we don't necessarily need to get a value for L and a value for C separately. In fact, when you get a question that's defined like this, I want you to think of this as a unit. 2L plus C. That is the thing that we're looking for the value of. I don't care how much one lamb's wool sweater is by itself. I don't care how much one cashmere sweater is by itself. I want that combination 2L plus C. So when I'm looking at the statements, I'm seeing, can I get to that relationship without maybe solving for the variables individually? And if we look at the first one, 3C plus 6L equals some number. Can I turn that into this? Yeah, if I just rearrange my L and C and then divide through by 2, or divide through by 3, rather, I'm going to get a 2L plus 3C equals whatever 570 divided by 3 is. I said, wow, whenever I'm talking while I'm writing, shouldn't be 2L plus 3C, it should be 2L plus C. Exactly, thank you. So that gives us some value on the other side of that equation. I don't care what it is, but it is a value. So that is sufficient. Statement 1 by itself works. But when we look at statement 2, each cashmere sweater costs, in other words, is equal to 25 more than a lamb's wool, so a lamb's wool plus 25. Well, that's a relationship between our two variables, but it's not the one that we need. So that by itself, not enough. So just statement 1 alone was sufficient, and we get A. So here, the trick was, if you're asked for a combo, which is a non-technical way of saying if you're asked for the value of an expression, you might not need to find the variables individually. You actually want to think, how do I get that expression just by itself as quickly as possible? So here, we can convert statement 1 into the thing that we're looking for. All right, let's take a look at that last one, which I think is probably the trickiest one. Did anyone catch the trap here, or the sneaky thing that was happening? Well, okay, so we were talking about, okay, we're starting with word problems, we're going to translate them to algebra. So let's start with just translating this. We've got 7 boxes of candy, or 7 apiece. So we could say it's going to be 7 times the candy. I don't know, you could do B for boxes, C for candy, either one, doesn't really matter here. And then popcorn is 11, so 11 times the number of boxes of popcorn. Here, that was a weird looking P. 7C plus 11P is going to equal some total dollar amount that was spent, right? So we have some, at least, setup of the information, but we definitely don't have an equation, a full equation that we can construct from the givens. And we want to know how many tins of popcorn. So P equals what, or T equals what, or whatever variable you use there. So, okay, if we translate the statements into algebra, the number of boxes of candy was 2 more than the number of tins of popcorn. Okay, so I'm using C and P. The candy, number of boxes of candy was 2 more than the popcorn, so popcorn plus 2. All right, well, that, as an equation, that's one equation, 2 variables, and we don't have any given, so that's not enough, right? And then statement 2, we spent a total of $68. Okay, so now we get to finish this equation up here. So 7C plus 11P equals 68. All right, well, by itself, that's just one equation, 2 variables. Again, it's not going to be enough. So it really, really feels like we should need to use these 2 together to answer the question, right? Feels like the answer should be C. But here's what I'll tell you. if this wasn't the question, if it was just pure math land and it was like, what is the value of P? In statement 1, C equals P plus 2. Statement 2, 7C plus 11P is 68. If this was the question, the answer would be C. But because this is the question, the answer is not C, because there's an additional constraint, an additional thing that we know because it's this word problem that we would not have known if it was pure math. If anyone knows, tell us in the chat, what constraint do we have in this word problem that we would not have in a pure math situation? Has to be a whole number. You can't go into a store and buy a third of a box of candy. You have to buy the whole thing. It is implied that we have to buy these in whole numbers. We have an integer constraint here. This would be different if we flipped it around and said, we bought 7 boxes of candy. How much did they cost? A dollar amount does not have to be an integer, but an object, countable objects, people, boxes of candy. When we're buying, apples and bananas at the store, yes, you can cut a banana in half, but be pretty weird to go into the store and buy half a banana. So it is implied that we're looking at integers. So Ava, to go back to the question that you asked earlier, can we ever solve with just one equation? We can. Look at this equation. And my question to all of you is this: are there a bunch of combinations of multiples of 7 and multiples of 11 that are going to add up to 68? There's only one combo that works. Now, how do we know? Okay, this is the really annoying, frustrating part. You have to actually just chart it out. I hate this. I've seen a couple of these on the real test. I'm always like, oh, don't make me chart it out. Please don't make me do it. But we have to confirm that there's only one combination that works. So here's how I would do it. I would say, okay, let's look at multiples of 11 in a chart and then multiples of 7, because multiples of 11 are really easy to chart out. So like 11, 22, 33, and so on. And I would just chart out all of the multiples of 11 because they're easy to generate. Actually, let me give myself more space to do that because that is easier. So we've got 7C on this side, 11P on this side. And what we want to do is chart out things that add up to 68. So we've got 11, 22, 33, 44, 55, 66. And I can stop there because 77, we're now over our total. So then what I would do, I know that my total has to be 68. So I'm going to go through and just see what plus this multiple of 11 adds up to 68. And is it a multiple of 7? So if it were 66, that would have to be a 2. So no, that's not a multiple of 7. If it were 55, then we're looking at 13. No, that's not a multiple of 7. If it were 44, then we're looking at 24. Nope, not a multiple of 7. This is tedious and annoying. Believe me, I hate this as much as you hate watching me do it. 35. Okay, yes, that could be a multiple of 7. Let's see if there are any other possible options. 22, we're going to look at 46. No, not a multiple of 7. 11, that would be 57. No, not a multiple of 7. And that means that the only thing that works where a multiple of 7 plus a multiple of 11 added up to 68 was this combination. That has to be the answer. So we had to have bought 5 boxes of candy, and then 3 tins of popcorn. She must not have very many employees that she's buying things for. I don't know, but this is the only option. So, okay, we'll come back to, and Eva, that is a really good point. We are going to talk about that in a second, but first, just to kind of sum this one up, the trap that was going on here was that we had an integer constraint, and if you have that implied integer constraint, it may be the case that there is only one combination that works for a given equation. So when we turned it into algebra, here's what it looked like, but we had that idea that they're both positive integers. We didn't talk about that first statement and whether that would be enough, but probably it's pretty easy to see that if this is 2 more than this, they really could be any 2 values that are 2 apart. Plenty of possibilities for that. But with this one, there were only 2 values that fit. But this is a really great point about how do we know when we should chart it out and when we don't? When should we be expecting just one possibility versus multiple possibilities? And there is an easy way to tell. If we come back to here, let's do a little sidebar and let's change the question. Let's say boxes of candy are now in this new universe $8 a piece, and tins of popcorn are $12 a piece. And let's say that this statement is she spent $72 total. Wow, I can't spell the word total. Okay, gut feeling on this one. What do you think? If I changed the coefficients here to 8 and 12, and now my total is 72, is this going to be enough? No, because we can envision 72 is a multiple of 8 and 12. There are a bunch of different ways that 8 and 12 overlap. They share a 4. So we can picture a lot of overlap there. A lot of different ways that a multiple of 8 plus a multiple of 12 could add up to 72. So the difference is if your coefficients do not share any factors, it's much more likely that there's only one combo that works. Because you'd have to, basically, it would take like many more multiples thereof. I mean, if the total was something giant, if the total was in the thousands, okay, maybe there's a chance that then they overlap. But if your coefficients are 7 and 11, these are both primes, there's a really good chance that there's only one combo, one total that fits those in this integer constraint case. But if your coefficients share factors, probably the more than one situation works. So you probably need 2 equations. So what do you do on test day? It really comes down to how much time you have. And I know this is frustrating. I know that you kind of want a silver bullet, but a lot of things on the GMAT come down to decision making. Do you have the time to do it or do you not? If you have the time, quickly chart it out and confirm, yep, there's only one multiple of 7 plus a multiple of 11 that adds up to 68. But chances are you're going to be a little bit pressed for time. You're not going to want to spend that time. So I think you should trust your gut. And if your your coefficients don't share any factors, trust that this is sufficient, pick it and move on. Or mark it to come back to. and chart it out to confirm if you have time left over at the end, because the GMAT now lets you mark things to go back to if you finish a section early. So these are all really tricky because we looked at the top, we looked at a couple examples where we needed 4 equations for 4 variables. We needed 2 equations for 2 variables, right? Sometimes that is the case, but then sometimes they can mess with your expectations. And if it feels a little too easy, it just might be. Look for those traps, integer constraints, combos, and then the secretly the same equation idea. And basically, if you notice that you've gotten something like this wrong, really think about where in your process to fix that. Were you not doing enough work, or were you doing too much? So on data sufficiency, it's like you don't want to do too much work. Don't spend the time to actually solve, but do just enough to confirm that it is actually solvable. So we went through all of these, our takeaways here about the integer constraint. So really, the broadest takeaway overall is that don't assume that the golden rule of 2 equations, 2 variables is always what it seems. Be expecting the GMAT to mess with you. Be expecting them to set traps. They're sneaky. They really like to mess with us. So just be on the lookout for those traps. And if you want help with this stuff or with any of the content on the GMAT, TTP offers live classes now, in addition to the self-study courses that you know and love and that are award-winning. We now have live classes where you can sit with an instructor who makes terrible jokes and makes mistakes and things like that, but you can have someone help point you in the right direction. You can work with other students who are in your same boat and work on these things together. So my students can attest it's frustrating, but it's also a lot of fun to take that class together. Oh, Adam, thank you. That's so sweet. It was wonderful to work with all of you. I'm so glad you all tuned in. Thank you so much. And I look forward to seeing you in the next session, and good luck with your studies. Take care, everyone.